at 2:17 p.m. on October 8, 1895. Construction foreman James O'Brien stood at the edge of a tunnel collapse beneath Tremont Street in Boston, shouting names into darkness that had just swallowed 3 of his workers. Michael Brennan, age 34, father of 5. Thomas Riley, 29, newly married. Patrick Walsh, 41, worked construction for 22 years. They'd been digging a subway tunnel when the floor gave way. Standard procedure said wait for rescue crews, shore up the collapse, excavate carefully. But O'Brien heard something that changed everything. Running water. Not dripping, not seeping, flowing, fast. The city engineers had said there was no water down here. The geological surveys showed solid bedrock. The maps indicated no streams, no underground rivers, nothing. Just granite and clay. But O'Brien could hear it, and his men were somewhere in that water, in the dark, possibly drowning in a river that wasn't supposed to exist. This is the story of how 3 workers proved Boston was built on top of a hidden waterway, how their disappearance revealed infrastructure nobody knew existed, and how sometimes the ground beneath a city holds secrets even the engineers don't understand. Boston in 1895 was building America's first subway system. The project was ambitious, digging tunnels through densely populated downtown, beneath buildings that had stood for 200 years, under streets that handled thousands of people daily. The engineering challenge was immense, but the geology seemed straightforward. Boston sat on bedrock, solid Roxbury pudding stone, and Cambridge argillite, deposited 600 million years ago. The rock was stable, predictable, perfect for tunnel construction. That's what every geological survey said. That's what the city engineers believed. The Tremont Street tunnel section was scheduled for completion in November 1895. The crew had been excavating since August, making good progress through soil and bedrock 40 feet beneath street level. Standard cut and cover method: dig down from the surface, build the tunnel, cover it back up. The crew worked in shifts, 60 men total, divided into teams of 20. O'Brien supervised the day shift, had been foreman for 8 years, knew tunnel work inside and out. The tunnel floor on October 8th showed no warning signs. The crew had excavated another 15 feet that morning without incident. The rock was solid. The shoring held. At 2:14 p.m., Brennan, Riley, and Walsh were clearing debris from the tunnel floor when the ground beneath them cracked. Not collapsed, cracked, like ice breaking on a frozen pond. The sound echoed through the tunnel. Then the floor dropped. The collapse wasn't gradual. The men fell 12 feet straight down into a cavity that shouldn't exist. O'Brien was 30 feet back when it happened. He ran forward, looked down into the hole and saw water, black water, moving fast, visible in the lamplight from the tunnel above, and his men were gone. He called their names. No response, just the sound of rushing water. The rescue crew arrived at 2:34 p.m., led by Captain Daniel McCarthy, Boston Fire Department. McCarthy brought rope, lamps, and 4 men trained in confined space rescue. He looked into the hole and immediately recognized the problem. This wasn't a collapsed tunnel section. This was a breach into something else, a void, a passage, and it was flooded. McCarthy ordered his men to lower rope with a lamp attached. The lamp descended 12 feet, touched water, then disappeared below the surface. They couldn't see bottom. McCarthy pulled the lamp back up. The rope was wet for 8 feet below the water line. That meant the cavity was at least 20 feet deep, 12 feet of airspace, 8 feet of water, and possibly more below. 3 men were somewhere in that space, either trapped in air pockets above the water or already drowned. McCarthy made the call. He couldn't send rescuers into unknown water in the dark. Too dangerous. They needed pumps to lower the water level, engineers to assess the cavity's structure, and diving equipment if the water couldn't be pumped out. That would take hours. The trapped men didn't have hours. But sending rescuers into a death trap wouldn't save anyone. The pumping began at 3:47 p.m. 2 steam pumps, each capable of moving 500 gallons per minute. They dropped hoses into the cavity and started drawing water. The level dropped slowly, too slowly. McCarthy realized the cavity wasn't just a pocket. It was connected to something. Water was flowing in as fast as they pumped it out. There was a current. That meant a source, a continuous source. At 5:23 p.m. with daylight fading, McCarthy heard voices, faint, coming from the cavity. He shouted down. A voice responded. It was Brennan. He was alive. He and Riley were trapped on a ledge 15 feet below street level, just above the water line. Walsh was gone, swept away by the current when they fell. They'd been in the water, managed to find the ledge, pulled themselves up. They'd been waiting in darkness for 3 hours. The rescue took another 2 hours. McCarthy couldn't lower men on ropes because the cavity was too narrow, and the ledge was unstable. Instead, they built a wooden ladder system, braced against the tunnel walls, extending down to the water level. At 7:41 p.m., Brennan and Riley climbed up, hypothermic, bruised, terrified, but alive. Walsh's body was recovered 3 days later, not in the cavity, half a mile away, in the Charles River. He'd been swept through an underground passage that connected the cavity to the river. That's when the city engineers realized what they'd breached: an underground stream, a forgotten tributary of the old Stony Brook, a waterway that had flowed above ground until the 1820s, when it was covered over during Boston's expansion. The engineers thought they'd buried it completely. They hadn't. They'd just built over it. The stream continued flowing underground, carving through clay and fractured bedrock, creating passages that no geological survey had detected. The discovery changed how Boston approached tunnel construction. The city commissioned a comprehensive underground water survey, using test drilling to map subterranean water flows before any excavation began. The survey found 7 underground streams beneath downtown Boston, all buried during 19th century development, all still flowing. The Tremont Street cavity was one of the larger ones, a passage 6 feet high, 8 feet wide, carrying approximately 2,000 gallons per minute toward the Charles River. The subway construction continued, but with new protocols. Any tunnel section near mapped underground streams required advanced drilling to confirm water presence and flow rate. Pumping systems were installed before excavation began. Rescue equipment stayed on site during all work. The changes added cost and time, but they prevented another catastrophe. The remainder of the Tremont Street Tunnel was completed in March 1897 without further incident. The underground stream was eventually diverted into a new culvert system, built specifically to route it safely around the subway tunnel. The culvert still operates today, carrying the old Stony Brook tributary beneath modern Boston. Most residents don't know it exists. They walk over it daily, ride the subway next to it, work in buildings built above it. The river that nobody believed in still flows, hidden 40 feet underground. James O'Brien continued as tunnel foreman until 1903, supervised construction on 3 more subway sections. He retired at age 51, died in 1914 at 62. His obituary mentioned his work on Boston's subway, but didn't mention the collapse, the rescue, or the fact that he'd been present when Boston discovered it was built on top of a hidden river system. The engineering community remembered differently. The American Society of Civil Engineers cited the 1895 incident in a 1920 report on urban underground water management, noting that O'Brien's quick response and McCarthy's cautious rescue approach had prevented a larger disaster. Michael Brennan returned to construction work 2 months after the incident, but never worked underground again. He became a bridge carpenter, worked on elevated sections where he could see sky. He died in 1921 at age 60. Thomas Riley left construction entirely, became a dock worker. He never spoke publicly about the incident. He died in 1934 at age 68. Patrick Walsh's widow received $2,000 in compensation from the city and the transit company. It wasn't enough. She raised their 3 children working as a seamstress. The youngest son, Patrick Jr., became a civil engineer. He specialized in underground water management, dedicated his career to ensuring no other workers would drown in rivers that weren't supposed to exist. The lesson isn't about subway construction or geological surveys. It's about the gap between what we think we know about the ground beneath us and what's actually there. Cities build over streams, bury waterways, pave over wetlands, and assume the buried infrastructure disappears. It doesn't. It just becomes invisible. Boston's underground streams still flow, still carve passages through fractured rock, still create voids that can collapse without warning. The difference now is that engineers know to look for them. Because 3 workers fell through a tunnel floor in 1895 and proved that sometimes the most dangerous infrastructure is the kind nobody remembers building. If this story moved you, please like and subscribe. Tell us in the comments where you're watching from.